All right, here we go. We're working now. So let's do 5 and 10 for the video, and 8 is posted in a different video. Number 5, that looks like, well, you tell me, do you know what it looks like? Looks like tangent. For tangent to work, that would need to be, they're also out of order than what we usually like, but u squared and a squared. If it's tangent, it needs to be that. So if u squared is x to the fourth, then what is u? X squared. A would be 4, that's the easy one. Du would be 2x dx. Okay, so that's good news. So if I just put a 2 and a 1/2, then we're good for having du in the numerator. So 1/2 integral of du. If you really want to make it look like the formula that we had, we could switch the order of these, if that makes you feel better. A squared plus u squared. But the a always has to be the constant, and the u always has to be the thing with the variable. So the order doesn't matter because it's addition, but if you really want to put them in the normal order, you can do that. All right, so that's 1/2, 1 over a, inverse tangent of u over a plus c, but I need to plug in u and a. Remember, tangent has the extra a in the word, so it has the extra a out front. So 1 over 2 times 1 over 4, inverse tangent of x squared over 4 plus c. You pick the right u and a, things work out well. It's kind of always the case.
That's when the top is bigger than the bottom.
When the code.
All right, number 10, find the area between 0 and 1 down to the y-axis. I have no idea what this thing is, so I'm a little hesitant to sketch a graph. I guess I could plug in some numbers. If I plug in 0, I get 1/2. If I plug in 1, I get square root of 3, 1 over square root of 3, which is even smaller. No, that would be bigger than 1/2. No. 1 over 2 and 1 over 3 would be smaller. It would be smaller. I don't know. I don't really need a picture, but that maybe reminds me that this is really just find the area means integrate from 0 to 1. Of that function, and that will tell me the area under the curve. Even if I have no idea what the graph looks like, I'm just trying to get a visual. So what does this look like? Looks like inverse sine, a squared minus u squared. And it looks like things match up pretty well. A is 2. U is x, which we like because then there's no du dx fixing things we have to do. I guess maybe out of habit we should say du equals dx. So I don't think I'm going to rewrite it with a's and u's. I think I'm ready to just say this is the inverse sine of u over a, x over 2, from 0 to 1. Not finished yet, because I need to evaluate that at 1 and 0. So inverse sine of 1/2 minus inverse sine of 0. Now, I am finished there, if you want to be, because that is calculator ready. Like that's not calculus, that's calculator stuff, can handle that. Now, on a multiple choice test, so yes, that's a safe stop. Inverse sine of 1/2 is pi over 6. Inverse sine of 0 is 0. So multiple choice test is probably going to have pi over 6 as the answer. So the area under that curve is pi over 6.